Hi, this is Haishao Wang, and today we're going to talk about the longest increasing path in a matrix. Given an n by n integer matrix, we are supposed to return the length of the longest increasing path in the matrix. And there are some rules about the movement. So in this kind of the matrix, the longest increasing path is from this cell and then move left and move up and move up, which is 4. So we just return the 4 as our output. And to solve these problems, I will use a hash map to help to solve these problems. And the key here is just the positions of a cell that in the matrix, and the values here will be start as the position at ij in the matrix. The longest path length, the length of the longest path from this node, from these cells. And then we just start from enumerate every cells in the matrix, and if it's not visited, which means that if that cell is not in this kind of hash map, we will just start depth first search and to find the longest path and store that information in the hash map. And if we already visited, we just return the longest path for that cells at a position ij. And after doing all of this, for the matrix, there are m multiple by n cells in the matrix, and there will be m multiple by n keys in the hash map, and we just return the maximum of the values in the hash map, and that will be our result. So define the DFS function first, and there will be the 3 parameters. So first one is, the first 2 is just the positions of the cell, and the third parameters will be the previous values. And I will just pause and to finish the main functions here. And first we just get the size of the matrix. And just enumerate every element in the matrix. And if the positions is not visited, which means that it's not in the self.history, we will just go through its ij and start from -1. I used -1 here because all the values in the matrix will be positive, and so there's no possibility that the first element in the matrix that will be less than -1, and which will make it into a base case. So we try to prevent that. So we just use -1 here. And after doing all this, we just return the maximum of the history values. And then we'll just finish the DFS part. So the best case is that if the ij is out of the boundaries, which means that I less than 0 or I less than m. Oops, I think they will be a greater or equal then. And the second corner case is that if the current ij is less than the previous, because we want to find a longest path, so that will be the base case here. We just return 0 because we do not find the valid path here. And if the ij is in self.history, we just return self.history. Actually, this is mean that if, for example, we just enumerate the 6 here, and we found that the longest path start from the 6 will be the 2, which is 6, 9. And in the next round, if we try to start as these 2, and it will go up and find the 6, and actually 6 is already in our hash map, we just return the 2 here. So this can boost the efficiencies of the algorithm. And for this, we just initialize the L to be 1, and should be max L and 1 plus DFS ij matrix. Actually, this kind of just the 4 directions of the movement, and this update is just noted for. It means that we try to find. We start at this kind. For example, we just start at these positions of the cell, and we try to find the longest path. If we move right, if we move down, and if we move up, and if we move left, and we just maximize the longest the path length. So finally we will get the L, which is the longest path that start from the cell at the positions ij, and we just we just add it to our hash map to be L and just return L. I hope this will works. Oh, I think this will be less because we want to sell increasing path. So equal here should also be the best case. Yeah, it works. That's pretty much about these problems. Thanks for watching.